Hello, welcome to the Stair Layout Lab for the Building Construction Technology program for Pikes Peak Community College. These are the items that you will need: performance profile sheet and the detail sheet. These will go together. This is a summary of what you'll be covering, and this goes into more detail on what you'll be covering. Carpenter square, 2 stair gauges. You'll see a close-up on those a little bit later. Jigsaw, circular saw, and eye protection. Ear protection is not required, however, I enjoy being able to hear, so I recommend using earplugs. And then the material will be a piece of 1/2 inch OSB, 1/2 inch thick, roughly anywhere from 11.5 to 12 inches wide, depending on what was actually ripped to, and it's 8 feet long. That's what you'll be using for this lab exercise. I'm going to set the tools down, the saws that is, and we'll focus on the square and gauges. Have your sheet smooth side up. And what you'll do is line up your framing square to the rise and run indicated on the detail sheet. Detail sheet indicates for the rise 7.5, for the run 10.5. Those dimensions fall within the code requirement in El Paso County, Colorado, which is where we are. There's a maximum rise, maximum height, each step goes up, and a minimum width for the tread. So once you determine that, 10.5 here, 7.5, that's what the rise and run are for this exercise. You install the stair gauge so that you can simply slide the square up and down the riser. This piece of OSB will be the riser. Now, sometimes OSB is used for curved stairs, circular stairs, to build a stringer with a curve in it. You can start at either end, top or bottom. You just have to indicate on the riser what end of the riser is which. So I'm going to start at the top, 7.5 inch rise, 10.5 inch tread. Now if you notice, I'm a little bit in from the end of the riser. The reason for that is I have in mind that I want to be able to work in another tread. As you've gone through the content on laying out a stringer for stairs, there are so many risers and so many treads. Typically there's one less tread than there is risers. Or excuse me, one less risers than there is treads, because the last riser is the upper floor to which this will be attached. So that's why I'm starting from the end, so that I can work in a riser and also get the maximum use of the material. So I measure from the face of this, which is a riser reference, back over 10.5 inches, and I measure at the 7.5 for this rise height, basically in line with that point, to make sure I have enough space. So I can actually move this back a little bit to about there, and that will get me within 1/2 inch of the end of the OSB riser material. Now you can use a carpenter's pencil or a pen. just make sure, whichever you use, that you have a fine point on that. Because it does make a difference, the thickness of the line, once you go into cutting the stringer. I prefer a pen, but I put a fine point on this pencil. Mark your riser line. Mark your tread line. When you're marking, also mark the edge of the material. It's good to get in the habit of doing that, because lots of times you're using a 2x12 for a stringer, or a 12-inch Versalam or 11/7/8 Versalam or Microlam engineered product, and the corners typically have a little rounding over, and so you want to make sure that your reference is in the correct plane, which is the edge of the board. So that's why the face or the edge of the board is marked as well. And what I will do is also continue that first, or that actually would be the second tread line, all the way to the back, measure up to 7.5. Now if you notice, I'm holding that on 8.5, but I will be marking the 1 inch, and that's just for accuracy in marking. Once that is marked, take the framing square, line it up with, again, the mark on the face of the edge of the material. And that becomes one of the treads. And I will also measure 10.5 back. I'm holding it on 11.5, again, that's for accuracy, and marking on the 1 inch mark. 11.5, 1 inch mark, because our tread is 10.5 inches wide. And then mark the back of the stringer. So these lines is where we will cut the stringer once we have it all laid out. Your detail sheet shows 7 risers on this. So what I'll do typically is mark the risers as I go. This is the top of the stringer, but there's one more step, because it's going to meet the platform, the upper platform, upper floor that will join at the stringer. So that's 1, 2 risers, and I'll just keep going down the stringer until we get to 7. So I mark 7.5 at the mark that's on the edge, 10.5, mark the edge, draw your tread line, riser line, slide it down, line it up again with the mark on the face, mark the face, tread line, riser line, line it up with the mark on the face, mark the face, and then draw your tread line, riser line. And just keep going with that process. Mark the face, line it up, 7.5 at that mark, mark the face. Okay, now I'm pretty much to the end of the stringer, so I'm going to go back and mark the risers. We've marked 1 and 2, this is 3, 4, 5, 6, 7. That's 7 risers. Okay, so the bottom of this riser is 7.5 inches. So I want to mark from at riser 6, where it meets the tread, mark 7.5 inches, which means 8.5 if I'm holding it on the 1 inch mark, which I typically do for accuracy. Connect those points. We have 7 risers. 1, 2, 3, 4, 5, 6 treads. Always one less tread than risers. Now, part of calculating in marking a stringer will be taking into account the thickness of the tread material. So it'll range between hardwood, carpet, whatever material you're using on the stairs, the upper floor and the lower floor. You have to take that into account when you're cutting this. You're also taking into account the riser material that's being used. Now, for a rough set of stairs in your typical home, the tread material, the rough tread and the rough riser material is 3/4 inch OSB or plywood, CDX plywood. So for the riser material being 3/4, you're adding that to the face of the stringer. So if we add 3/4 to the face of the stringer, draw that line. And then we add 3/4 to the top of that cut for the tread material, which is 3/4. So, without doing anything to the back of the stringer at the top, and we've added riser material, we end up with 11.25 tread dimension. Now, as we go down the stringer, say we add 3/4 to the next riser, so we measure from the riser material, the face of it, to the face of the previous riser material. We have the 10.5 inches, which is the unit run on the detail sheet. But up here, we have 11.25. It's 3/4 of an inch greater than the one below. The reason is we've added material here at both spots so it evens out. It doesn't even out here because we still have material here that needs to be taken off. So we subtract 3/4 of an inch from the back vertical cut, plumb cut on the stringer. So the stringer will actually be cut back 3/4 of an inch on the last plumb cut here. We won't do that accommodation for the tread space because once you get down to the lower floor, the finished material will be added to this. So it will balance out. So let's, for argument's sake, say this line represents the slab on which the stringer rests, and then we add 3/4 of an inch to this. From the slab to the finished material is 8.25. That's over our maximum allowed by code. But when the finished material gets added down here, let's say carpet, that's anywhere from 3/4 to an inch. That'll put us under our maximum. However, when the finished material gets added to here, to each step, that will offset the dimension, so we will actually be greater than the maximum allowable rise. So we'll do a similar thing like we did on the back of the stringer. We're going to do to the bottom of this last horizontal line is subtract that rough tread material, which is OSB, 3/4 OSB or 3/4 inch CDX plywood. So we have a new line with the finished material being put on the subfloor material. That gets us back to within the 7.5 inch rise that's on the detail sheet. Okay, so now that we've taken off the bottom 3/4 of an inch for the bottom of the stringer, from the rough material, tread material to the floor, we will be at 7.5 inches. We add finished material, whatever it is here, usually carpet, that's another 3/4. Carpet down here, another 3/4. It offsets itself, so the rise, required rise, your calculated unit rise is maintained consistently as you go up and down the steps. The building code does allow for a 3/8 variation in that rise dimension. So meaning this can be, instead of 7.5, 7 3/8, 3 steps up, this can be 7 5/8. As long as it stays within 3/8 variation, then the building code will allow you to leave the stairs in place. But you do have to go through the process, taking the time to make sure that your calculations are correct. So now that the stringer is laid out, it will be cut. Now we won't cut it completely because we want to do what's called a dry fit for the stringer, which means we're simply going to cut the top end lines and the bottom, both the plumb and horizontal lines on both bottom and top. Remember to wear your glasses. Now, one thing I didn't do at the top that I typically do is mark the actual line that I will be cutting. So I'll do an arrow to the cut lines all through the stringer, what I'm cutting. Specifically, if I put lines down that are symbolic of the finished material, be sure to put an arrow pointing to the actual stringer cut. So there's an arrow here for the tread cut, here, all the way down. Okay, so this is a dry fit piece. We're only doing those 2 cuts up the top. We'll do 2 similar cuts down here. So as you go, before you're ready to do a dry fit and check this in place, confirm with your detail sheet the number of risers and treads you need. So remember, we marked them. So we'll start from the bottom. Riser 1, riser 2, riser 3, riser 4, riser 5, riser 6, riser 7, and then the upper landing is the 8th riser. Double check your detail sheet. It tells you the total number of risers, total number of treads. So we just counted 8 risers. Now we're counting the treads. 1, 2, 3, 4, 5, 6, 7. And technically, the next landing, the next floor, that is the 8th tread. Okay, so now that we've confirmed, we'll do a dry fit in place. Okay, so now that we've got this cut, we've confirmed the number of risers, number of stringers, confirmed our dimensions are drawn correctly. On the stringer itself, we do the cuts at the top, cuts at the bottom, allowing for tread material and riser material. So this represents the frame of the upper landing, upper floor system to which the stairs will be attached. This particular space is 3 feet wide, standard rough dimensions for a set of stairs, minimum width. Got 3 stringers typically are used. So what's laid out on this header that represents the floor system above are where the stringers are. We've laid out the subfloor material, which is 3/4 of an inch here. The top of that line is the top of the subfloor. The bottom of the line is the bottom of the subfloor and the top of the stringer, which is going to be this line here. So this top line we've measured from the top of the subfloor of the upper landing, which is 3/4. We measured down the 7.5 inch rise from the detail sheet. Another 3/4 for the thickness of the material that is going to be used for the tread, 3/4 of an inch. That's how we determine these lines. So, bottom line is where the top of the stringer itself should line up. Once that is placed at that height, we look down at the floor, and that horizontal line sits fairly level, fairly snug, all along the cut. So one of the purposes of doing a dry fit is if you have a lower floor that's out of level, this can be your pattern to make any adjustments along this cut. So for example, if the slab is too low here, then you take some off the front. Whatever the thickness is, whatever the difference is between the stringer and the floor, you remove that off the front. If the surface is too low on the front, on the nose, then you remove that difference from the back and then it'll sit flat. And you'll check it at each stringer location, because there's no guarantee that the slab is going to be completely level along the width of the stairs. So that was the center stringer. Go over and check the first outside stringer. That looks pretty good. So no adjustments needed there. Line it up with where the top of the stringer should be. That looks pretty good. It's sitting flat on the slab. So once that is confirmed, then you can go back and cut out each piece for building the stairs. Install your first stringer, install your second stringer, and install the third stringer with all these cut out, and then you can start applying your riser first and then your treads. All the risers get installed first, and then the treads get installed after the risers are installed. The back of the stringer, if there's no support along the full cut, vertical cut, the code requires a steel strap that will cause the stringer to hang from the main floor. So the strap will be nailed to the floor header and the back of the stringer.
Like a joist strap?
Yes, it's called an FHA strap. H stands for heavy. It's a heavy duty strap.
Specifically for stringers?
Specifically for stringers, yes. And that is the exercise for laying out and cutting stair stringer.
Question is, why would you use the steel strap hanger instead of just adding a little piece to the bottom of the board?
Well, you can add more support to the back if you have something to which you can attach it. For example, the floor system is that wide to go all the way to the bottom of the stringer. You can add that if you have a support back behind it that's a structural support, not just another wall, because it could be a basement wall, which is non-structural. The other thing is that, say for example, in this particular scenario, there's a stud behind there that's structural. This stringer can be cut to where it extends and attaches to that stud. So that's one area where you have some flexibility, creativity in making the connection. The specific scenario of each location will dictate what's needed for the stringer support. Many entry-level homes, there's minimal space available, so you won't have the support here, so the strap will be needed.